question addresses using a polyvinyl chloride or PVC nipple instead of a rigid nipple between the meter and the service disconnect to prevent parallel return paths. The focus is on whether there's a factory-made polyvinyl chloride or insulated nipple, or even an offset nipple, available, or if the common practice involves using two terminal adapters, or TOS, and a short piece of polyvinyl chloride. The narrator indicates they've also never encountered a factory-made offset nipple. In the past, the narrator used two terminal adapters and a short segment of polyvinyl chloride to fashion an offset. However, they observed that the terminal adapters tended to sag between the disconnect and the meter base. Some time ago, the narrator discovered an alternative approach. If you acquire approximately a 6-inch piece of 1-inch polyvinyl chloride and introduce a slight bend into it, you can do this by using your feet. It will generally maintain its position as long as the lock nuts are securely tightened. The narrator suggests that this method appears to be just as effective as any other approach, and it offers a cost-effective solution. It's important to consider the National Electrical Code, or NEC, requirements for conduit fill, bending radius, and support when using polyvinyl chloride conduit. The NEC provides guidelines to ensure the safe and proper installation of electrical systems. When creating bends in polyvinyl chloride conduit, it's essential to use appropriate heating tools designed for this purpose. This ensures that the bends are smooth and do not compromise the integrity of the conduit. The NEC specifies minimum bending radii for different sizes of conduit to prevent damage to the conductors inside. Furthermore, the code outlines the required support intervals for polyvinyl chloride conduit to prevent sagging or displacement. These support requirements vary depending on the size of the conduit and the installation environment. When selecting polyvinyl chloride conduit for an electrical installation, it's crucial to choose the appropriate type and size based on the specific application. Factors to consider include the voltage and current levels, the environmental conditions, and the type of conductors being used. The NEC provides tables and guidelines for determining the appropriate conduit size for a given number of conductors, taking into account their size and insulation type. Additionally, it's important to ensure that all polyvinyl chloride conduit and fittings are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or UL. This ensures that the materials meet established safety standards and are suitable for use in electrical systems. When installing polyvinyl chloride conduit in underground applications, it's essential to follow the NEC requirements for burial depth and protection. The code specifies minimum burial depths for different types of conduit and wiring methods to prevent damage from physical contact or environmental factors. Additionally, it may be necessary to provide additional protection for the conduit, such as encasing it in concrete or using a protective sleeve. When making connections to polyvinyl chloride conduit, it's important to use appropriate fittings and connectors that are specifically designed for use with this type of conduit. These fittings provide a secure and watertight connection, ensuring the integrity of the electrical system. The NEC also specifies the types of fittings that are permitted for use in different applications, such as wet or dry locations. When installing polyvinyl chloride conduit in areas subject to physical damage, it may be necessary to provide additional protection, such as using a rigid conduit or a metal sleeve. The NEC provides guidelines for protecting conduit from physical damage in various environments, such as industrial settings or areas with heavy traffic. It is important to regularly inspect polyvinyl chloride conduit installations to ensure that they are in good condition and free from damage. Any damaged or deteriorated conduit should be repaired or replaced promptly to prevent electrical hazards. The NEC provides guidance on the maintenance and repair of electrical systems, including conduit installations. Consider factors such as thermal expansion and contraction, especially in long runs of polyvinyl chloride conduit. Expansion fittings may be necessary to accommodate these changes in length and prevent stress on the conduit and connection. The NEC addresses thermal expansion and contraction in conduit systems and provides guidelines for the use of expansion fittings. When working with electrical systems, always prioritize safety. To energize the circuit before performing any work, and use appropriate personal protective equipment, or PPE, such as gloves and eye protection. The NEC emphasizes the importance of electrical safety and provides guidelines for working safely with electrical systems. Adhering to the NEC and following industry best practices will help ensure the safe and reliable operation of electrical systems using polyvinyl chloride conduit. The electrical installations must adhere to local codes and regulations. Always consult with a qualified electrician. The information provided is for general guidance only. Always consult the latest edition of the National Electrical Code and local regulations for specific requirements. The NEC is a comprehensive set of standards for electrical installations and is updated regularly to reflect changes in technology and safety practices. Local codes and regulations may also have additional requirements that must be followed. A qualified electrician has the knowledge and experience to ensure that electrical installations are safe and compliant with all applicable codes and regulations. Incorrect electrical installations can create serious hazards, including electrical shock, fire, and equipment damage. It is always best to consult with a qualified electrician before undertaking any electrical work. Electrical work should only be performed by qualified individuals. The safety of people depends on the proper installation and maintenance of electrical systems. Take the time to understand the NEC and local codes. This can help you prevent electrical hazards and ensure the safety of your home or business. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always take precautions and consult with a qualified electrician when necessary. The NEC covers a wide range of topics related to electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians and other electrical professionals to have a thorough understanding of the NEC in order to perform their work safely and effectively. The NEC is not a design manual, but it provides minimum requirements for electrical installations. It is the responsibility of the designer or installer to ensure that the electrical system is adequate for the intended use and complies with all applicable codes and regulations. The NEC is constantly evolving to reflect changes in technology and safety practices. It is important to stay up to date with the latest edition of the NEC and any applicable local amendments. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and other sources. It is also available online through various subscription services. Studying the NEC and attending training courses can help you improve your knowledge and skills in electrical installations. Many organizations offer NEC training courses, including trade schools, community colleges, and professional associations. Continuing education is essential for electrical professionals to stay current with the latest codes and regulations. There are many resources available to help you learn more about the NEC and electrical safety. These resources include books, articles, websites, and training courses. Take advantage of these resources to improve your knowledge and skills in electrical installations. Remember, electrical safety is everyone's responsibility. By following the NEC and taking precautions, you can help prevent electrical hazards and ensure the safety of yourself and others. Never attempt electrical work that you are not qualified to perform. Always consult with a qualified electrician when necessary. Electricity is a valuable resource, but it can also be dangerous if not handled properly. By following the NEC and taking precautions, you can help ensure that electricity is used safely and efficiently. The goal of the NEC is to provide a safe and practical standard for electrical installations. By following the NEC, you can help ensure that electrical systems are installed and maintained in a way that protects people and property from electrical hazards. The NEC is a living document that is constantly being updated to reflect changes in technology and safety practices. It is important to stay up to date with the latest edition of the NEC and any applicable local amendments. The NEC is a valuable resource for anyone who works with electrical systems. By understanding and following the NEC, you can help ensure that electrical systems are installed and maintained safely and effectively. Always prioritize safety when working with electricity. De-energize circuits before working on them, use appropriate personal protective equipment, and follow all applicable codes and regulations. Electrical safety is everyone's responsibility. By working together, we can help prevent electrical hazards and ensure the safety of our communities. Consider the environmental impact of electrical installations. Use energy-efficient equipment and practices whenever possible to reduce energy consumption and pollution. Sustainable electrical practices can help protect the environment and conserve resources. The NEC addresses some aspects of sustainable electrical practices, such as the use of energy-efficient lighting and appliances. However, it is important to go beyond the minimum requirements of the NEC and adopt sustainable practices wherever possible. Working with electricity can be rewarding, but it is also important to be aware of the risks involved. By following the NEC and taking precautions, you can help ensure that your work is safe and effective. Remember, electrical safety is a continuous process. It is important to stay vigilant and to never take shortcuts when working with electricity. The consequences of electrical accidents can be severe, so it is always best to err on the side of caution. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. They can provide you with the information and guidance you need to work safely with electricity. Electricity is an essential part of modern life, but it is also a powerful force that must be treated with respect. By following the NEC and taking precautions, we can all help ensure that electricity is used safely and efficiently. Always remember that electrical safety is everyone's responsibility. By working together, we can help prevent electrical hazards and create a safer environment for everyone. Be aware of the potential hazards associated with working around electricity. These hazards include electrical shock, arc flash, and explosions. Always take steps to minimize these risks and to protect yourself and others from harm. Never assume that a circuit is de-energized. Always test a circuit with a voltage tester before working on it. Use appropriate personal protective equipment such as gloves and eye protection when working with electricity. Follow all applicable codes and regulations. Report any electrical hazards to the appropriate authorities. Participate in electrical safety training programs. Promote electrical safety in your workplace and community. By being proactive and taking precautions, we can all help prevent electrical accident. Electrical safety is a shared responsibility. It is up to each of us to do our part to ensure that electricity is used safely and efficiently. Always be aware of your surroundings when working with electricity. Look for potential hazards, such as damaged wiring or wet conditions. Take steps to mitigate these risks before proceeding with your work. Never work alone when working with electricity. Have someone nearby who can assist you in case of an emergency. Know the location of the nearest emergency shut-off switch. Be prepared to respond quickly and effectively in the event of an electrical accident. Electricity is a powerful force, but it can be managed safely if we take the necessary precautions. By following the NEC and being aware of the risks, we can all help prevent electrical hazards and create a safer environment for everyone.